Alright, my name is Silas and I'm presenting this section for Group 10. Project was Catify. So first of all, we chose this topic because as a group we wanted to experiment with facial recognition software, but we wanted to avoid some of the ethical issues that come with it, and also kind of do it in a fun way so that we would stay motivated. We're also inspired by the amount of cats we saw in the slides this semester. And thought it would be a good merging of the topics that we've learned. We've chosen Google and AWS to compare because we wanted to see if there was much of a difference between cloud providers when it came to facial recognition. AWS was able to compare human and cat faces by default, so that's why we chose them off the bat, because we knew at least could solve the problem with just AWS for sure, so we wanted to have a kind of default. We then chose Google because we were all kind of interested in seeing what Google could offer, because we'd worked with Azure and AWS. We wanted to see what Google brought to the table, and also comparing cat photos by default was not possible with Google, so we knew we'd have to work around a bit with what we were given and make the problem a bit more interesting. We chose to compare the two providers with metrics of speed and accuracy. This is because for our use case, which was going to be an Android app that compares human and cat faces, these are the two most important factors. We needed to be fast, otherwise the user would just be kind of waiting on a screen forever, and that's not super fun. We also wanted to beat the implementation of just like randomly choosing a cat photo, because obviously that's not very helpful for anybody if you just say, oh, what cat do you look like? Oh, here's some random cat. So we wanted to beat that, so we needed to be somewhat accurate at least. Alrighty, so what did we complete in the end? So if you later on in the cloud aspect section, you'll see we actually had to build quite a bit of cloud infrastructure around our backend, not just with the image recognition. So we did end up using AWS quite a bit for their other cloud offerings as well. It wasn't just image recognition. And we needed to build this in order to have an API to call from our Android app, because there's no integration between AWS and Android by default, so we had to create that integration. So we ended up using a lot more of AWS offerings than we had planned to, and a lot more than just the recognition software. We also ended up completing a very basic Android app that allowed users to compare their face to our subset of cats that we picked and determine which cat looked most like them based off a certain set of metrics. We obviously haven't ended up releasing this application because cloud services cost money and we're all students and we don't have very much credit left on our accounts after this semester. Alright, and you'll see more details of this when we demo it later on. Alrighty, so cloud aspects from AWS. What did we use? So we ended up using quite a bit for AWS, as mentioned before, because we did more than just image recognition. We also built our entire backend off of AWS. So you'll see here, this is the list of services we used. We used S3 to store our cat photos and related data. We didn't store any user data or anything like that, so we didn't have to worry about that aspect. We just stored our cat photos and then any related data to their facial structure. We used Lambda as our service backend. This was to run any of the functions we needed, like comparing the human and cat faces and various stuff to integrate with Google and so on. We used API Gateway to build our API as a way to call it from our Android, call our Lambda functions from our Android application. What we ended up doing was the APIs would take a JSON object containing an encoded image of a human face, or in Google's case, a list of attributes about the facial structure, and then it returns an encoded image of the cat that they look most like, and that's what we would display to the user. We used CloudFormation to tie it all together and put it in one place, and then obviously we used recognition to compare the human and cat faces for the AWS side. And like I mentioned before, it was pretty cool that by default AWS could recognize a cat's face and compare it to a human's face. This was something that Google couldn't do, and we had to get a bit more creative, and we'll explain that on the next slide. So with Google, what we ended up having to do is we could use Google to get a list of vertices on the cat's face of where their eyes were, where their nose was, and so on. So we use this information to calculate ratios between eyes, between nose, and so on. We would then, when the user uploaded their photo, we would then run the exact same analysis to get their ratios of their facial structure, and then compare those to the previous structures we had for the cats, and that's what we determined as similarities. So basically, once the user uploaded their photo, we would calculate the ratios of their face, compare it against all the cats, and then the most similar was the cat that looked the most like them. For this reason, Google API calls that we made were a lot quicker than the AWS ones, as you'll see later on when we demo it. And this was most likely due to the fact that we were comparing just facial structure data on the Google side, whereas AWS, who knows what they're comparing? It's all black box functions, so most likely they were comparing more than that, and therefore it would take a bit longer. But this also most likely impacted the quality of the results. But with our testing, it was good enough for our use case, so it was a pro for Google in this case. So we ended up, instead of building additional backend infrastructure to directly interface with Google Vision, we incorporated Firebase into our Android app, because as you know, Android very easily integrates with Firebase, and then you could use Firebase Vision to get the facial structure data locally on the Android phone, and then pass that data to AWS to perform the comparison. Firebase Vision also enables you to download the facial recognition model directly to your phone to speed up sequential calls, and this heavily increased the performance, because obviously you don't have to do a separate network call. It's all local, so it's quite a lot quicker. So as you'll see later on in the demo, it's quite a bit quicker than the AWS call.
Hello, it's Schwabe speaking now. I focused mainly on the AWS aspect of the project, so I'm going to briefly go over some of the AWS services we used, starting with the S3 bucket. The S3 bucket was just used to store the cat images and the cat data. The second service we used was the Lambda functions. The Lambda functions is where we had our code, our backend code. As you can see, the API gateway is what called it. This is just one of the functions. We used Python as the runtime, as it was straightforward to use since we used it in class. So a lot of the stuff I could carry over and help me with, especially calling S3 buckets. The next service we used was the API gateway. The API gateway would link up to the Lambda functions. So as you can see on the right, let's link up to the one. If you go into their stage, in dev, you can see this is the URL that you would need to invoke if you wanted to call the specific function. And then we also used CloudFormation. The CloudFormation was actually help generated using the serverless framework. So the serverless framework is a way to manage all AWS infrastructure, and it generates this kind of template designer that you can also make in AWS. But it kind of just shows the infrastructure we used, how it's connected, and just helps manage it. So you can see like cloud logs, API gateway, Lambda functions, bucket, it's all here. And so this helped actually with creating the API gateway, the Lambda functions, and the bucket. So if I actually delete this one stack, the API gateway, the Lambda functions will all be deleted as well. The other service we used, which is like the big component, is the Amazon recognition service. It mainly uses the face comparison feature, so you can compare between faces. And then we got this response back. The similarity is what we used to help identify the similarity between the human face and the cat face. So the highest similarity cat face returned, it was the most similar face that we returned. And as you can see, there's a bunch of different data you can get from it. So you can get left eye, right eye, all the location of this stuff. And you can even go, if you want further in depth. This is a bad image here. Try this one here. Just wait a second. If you look at the response, so it shows the guy's face in the middle, but you can even see his emotions, even more in depth of the landmarks. So the right eye, brow left, just more depth in-depth information here. And that's all our AWS services really used.
All right, so here I have the algorithm that is used to compare the AWS recognition and Google Cloud Vision facial recognition data, as they're very different. This is utilizing the adapter pattern to be able to actually interface the two different return types with different data. So for this example, I have the Google return data for my face here as inputted here, and it is going to compare it to the file returns of the various cat facial data here that is taken from AWS. And we are parsing all of these similar fields that are shared between the two, as they are not exactly the same, what types of fields that are returned from each service. So we found the ones in common and done some calculations to determine the relevant pieces of data that would actually compare facial structure data, such as the space between the eyes, the width of the mouth, and position of the nose relative to other parts of your face. So the way the algorithm works is, because we're comparing it to the set of cats we have predefined, the algorithm will take in the input of the Google data given the human's face, as shown here. This is the return data of my face. And then once it is run, it returns the differences of the various cats to the face. So the number here is the difference in terms of coordinate values, the total difference of the human face to each cat face. So as you can see here, there are various different values, and the lowest value between our set of cat images and my face is the Sphinx cat. So what it does is it returns the Sphinx cat to the app. So once this algorithm is used in the app, it is essentially having the app pass it the image and the cat images, and the algorithm will just run it all through and determine which cat face is closest to the human face provided.
Alrighty, so this is the demo of our app that we have made called Catify. So let's see, you have the option here to choose photo or take photo. I'm running it on an emulator so you can see the logs, so we won't take photos, but it does work. So we'll just choose photos for now. So if we choose a nice photo of a person, and then we'll choose Google for now because Google runs a bit faster, but you have the two options here of AWS and Google. We'll show AWS later on in the demo. Alright, so if we hit start there, brings us to a loading screen where it compares his face and gets the ratios of his face and then sends it off. So if you see here, it takes a little bit of time. There we go, it's a response. So yeah, so this is the cat that it matches with this person. We're just going to do that one more time to show you that it's not random results. It does return the same cat for each photo. So if we run that again with the same face, we should get the same photo back of the cat. Alrighty, so there's the response, and then there we go. So it does match the same cat with the same face. And then we're just going to do one more test here with a different face, so that it shows that it's not returning we don't only just have one cat that we return, it does actually pick different cats for different people. So a nice photo of Musk, see what cat he looks like. Try to run it with Google again because it's faster. And there we go. So that was a lot quicker because depending on the photo and the resolution and so on, it takes longer or shorter to find the facial structure ratios, and so sometimes it's a bit quicker. In this case, you see this is a very high quality photo, so that's why it was so quick. And there we go. It's a different cat. Not a very pretty cat, but that's all right. And yeah, so we'll just show you one more thing here. I'll show you with AWS. And same thing, see if we'll get a different cat, the same cat. Depending on the person, sometimes it's different matches, so we'll see. And I'll also show that AWS takes a little bit longer. The reasons for that are explained in the presentation and the report. But just, yeah, there we go. So that was actually pretty quick, but it was still longer than the Google comparison for Musk. So yeah, that's basically it. It's very simple, but yeah, there you go. Here's just a list of documentation that we use to create our various services. Any more information that you desire should be at these links. Alright, if we had to do this again, what worked well and what would we improve upon? The process of uploading images and integrating with AWS through their cloud offerings was quite seamless once we got everything up and running. So we definitely use all those services that we mentioned before, and maybe even more if we needed to, because the cloud definitely has a lot of good use cases for when you want to perform complex operations on a mobile device, but you don't have the horsepower to do so. So for applications like this, definitely is a huge advantage to interface with a cloud provider and perform those operations on the cloud and then download them back. Major providers like AWS have pretty much every single type of service that you could possibly imagine and want to use, so we would definitely work with those again and implement some of those. AWS was quite good for the back end aspect, and we would definitely use this again if we were to do it again. And if we were pressed for time, the fact that recognition could compare cat and human faces by default was quite handy, and we would definitely use that. Google shined in the fact that it was able to integrate with Android very, very quickly through Firebase. And also Firebase comes baked in with a ton of other features if we needed to use those, and it sped up performance quite a bit. If we were to do this again in a real setting, we would choose backend as our primary provider for image recognition, as we care more about speed than accuracy in this application. If we had a use case where we needed a higher level of accuracy, we would probably have to look around a bit or work with AWS a bit more to try and get a better job. Or also we could implement a more custom solution on our end to compare more than just facial structure ratios and improve performance that way. What would we change? So due to our time limitations, we were only able to collect a small set of cats, probably around 10 different species of cats, that because not all cats obviously would be recognized by image recognition. So we had to go through a ton of cat images, and we could only pick a certain ones that would work. And we always wanted some variety in species, so you weren't getting like you look like this cat or you look like this slightly different, but basically the same cat. So we wanted a variety of cats, but because not all cats could be picked up, it was quite time consuming to find a set of cats that would work. So if we had more time, we would want to increase this set so that we would get more variability in the results, as well as optimize the photos so that they appeared better on the user's end and also were smaller so that they can be compared faster. Yeah, related to this, we just want to optimize things for loading times because as you saw in the demo, things weren't as fast as they could have been. And yeah, that's pretty much about it. Thank you.